Alright, so this video is going to cover pretty much the rest of the game engine updates that we did this quarter. So I'll just start with the math tools, because I love going through the math tools. This is the second time I've recorded this video, in case you're wondering why I'm already irked. So I've got a good healthy number of functions this time around, instead of the, 4 that we had at the end of last quarter. The majority of them, number one, they're sorted, just for simplicity. But they are, the goal is to keep them as short as possible. Most of them are just a few lines. Pretty much all of them use the other functions provided in the math tools. And with the exception of the OBB and ABB and OBB intersections, none of them are this long. But these are well labeled, so I hope that this is okay for me. I hope you also think it's okay. But they are using like max OPP projection on V functions that are auxiliary and helpful for minimizing code reuse and the like. So that is math tools. Let me just make sure I covered it all. Boom. Yep. 6 pairwise volumes. Yes. As const reference, of course. Of course. Of course. Of course. Const ref. Amazing. Let's jump into the visualizer. I didn't really make a lot of updates to the visualizer besides the adding the capability to do really just boxes. That's really all we did this quarter. But also to allow more than, first of all, allowing more than one shape to be displayed, moving it from just the default bounding sphere to really anything else that we wanted to. But so I have the show B sphere, show ABB, show OBB. I have drop point, draw segment, draw ray. Point is the only one that works, but point is there's a capability to display different kinds of shapes with different kinds of dimensions. We have a single cube and a single sphere that are able to be drawn, so we're not creating new graphics objects every time. And then the visualizer is only called here in the scene. Right? Yes. So here in the scene we draw our 3D objects, we draw our visualizer, visualize all, and then we draw our 2D objects. And that, if I had transparency working, that would keep our transparencies neat and tidy and displaying correctly. Yep. Nope. Command pattern recycling pool. Great. Visualizer commands. We have the base command, bounding box command, vSphere commands. That's really it. As we can see from the commands, we don't have any spawning of new vSpheres or new boxes. And then for the commands themselves, if we go back to that little visualizer folder, we'll see that we have factories for the bounding box commands and the vSphere commands. I could probably push these two together and make them the same, but it's really simple for me to just have two. It's not too much of a burden. It would just be a little bit of code rewriting for that. And then this is where I messed up in the last. This is why I had to redo this. My visualizer wasn't being deleted. The place that makes most sense for the visualizer to be cleaned up is in the engine, even though I don't really like having the scene render the visualizer, but have the engine clean up the visualizer. But it does make the most sense because the visualizer being a singleton needs to be cleaned up at the end of. Oh my gosh, I didn't put a freaking breakpoint. There, in the destructor breakpoint. it makes most sense to have it um, in the game engine itself because it's part of the end cleanup of the game, and it's not that itself is not a scene level thing. Sorry for hitting the microphone. And really, the only reason that we have the scene talking to the visualizer at all is because number one, it matters when the visualizer is called, and number two, every frame the visualizer has a different set of commands that is then reset after each scene. Boom, destructor. I know you're gonna go and find that, but I've had a lot of issues with my destructors, so it's good that I'm going in now. Visualizer done. Let's wrap up these. Game object life cycle. I'll talk about that when I talk about my game. Scene update. I was just there. We open up our scene update. We do the registration, alarms, keyboards, collision, and then finally we update it, and that should stop us from having weird update or like having the weird issue where, for example, you can move into a wall and as while you're holding down a key, and then when you let go of the key, you reset back to being away from the wall. So we get all of our updates out of the way first, then we go through each object and we deal with everything, and then we draw. So that's how that works. Did that scene changing? I do a lot of scene changing, so we'll go over that then. Terrain, my nemesis. So terrain came at a part of the quarter when I was getting overwhelmed by everything. So the level of terrain that I have is the level of terrain that I have, and that's what you'll see. I do have a little diagram for it though. So if we want to just start in the manager, it's just another asset manager. It works exactly like the rest of the managers. It has load and get. It's stored in a map because we want to map strings, C strings, to terrain objects for easy accessibility. And if we look into load resources, we have that here, where we have in the terrain object manager load, we load the name that we want, the file, the texture, and then the dimensions of things that we want to give it. Terrain object is a drawable. It has some data. It has a graphics object, some some functions, draw, accessors, an alignment which isn't working right now, but I'll talk about it in a moment. The scene terrain manager is a scene level multiton, which is just responsible for getting and setting the terrain, and then the terrain object iterator iterates through all the possible collision cells that a collidable could theoretically in any given frame collide with, and it just takes a max I and a max j and a min I and a min j, and iterates through all of those. So when you load up a terrain object model, terrain object, when you load up a terrain model, we will automatically extract all the necessary information. Where I feel like I had more functions. This is not the right file. This is the right file. We read from the height map, set it all up correctly. My normals aren't working right now because I really never got around to them. But I'm using the same compute normals as I did in the graphics class, so I'm not even worried about the accuracy of those. I'm not using them, but I'm fairly confident in that function. Otherwise, we generate all the vertices, we read all the vertices, read into the height, generate the tries, create that whole thing, record the data that we want to store, and then create the model, compute normals function, and then we have, most importantly, the ability to get a specific terrain cell, and that is used in collision, here in the get collision area, which this function is used by our iterator, which has a beginning and an end, a max and a min, ABB point, and a current spot, and a pointer to the relevant terrain. And its next function is the iteration, and it just goes from the min to the max, iterating I and j, and resetting them as it should until it gets to the end. And all this is used in the collision commands. Boom. So we have our iterator. As we go through the collection with the iterator, we test the ABB in the cell pointed to by the iterator. If the cell ABB touches the object's, the collidable's bounding sphere, we go one step deeper. If the cell's AABB touches the collision volume, then we have a successful collision. We call the collision terrain of the collidable. So that is that, and if we go in, so in addition to not having any sort of barycentric or normal alignment, I also don't have the most efficient way to not or for testing if the collidable is over the terrain. There's just some, I don't even know if I can go off the backside and it would be okay, but the reason that I left that to be completed at a later date is because a good level designer shouldn't allow the player to get to the edge of the terrain, and there should really only be one terrain active at a time. If there was more than one terrain active at a time, instead of having like a current terrain, I'm not even going to talk about it because I'm not going to waste your time with that, but that's what I have. So as we approach and we start colliding, we see the green are the cells that collide with the default AABB, and then the red ones are colliding with the rest of the object, and then we're going to lag because that'll happen. But on this side, see, we're not on the terrain anymore, and we're not checking anything. And we have good frame rates, and then immediately we go over there. That's just something I'm dealing with. Sorry, I'm a little delirious. Been working on this for a while. Perfect. Okay. Cool. Great. So, in my last videos, I will do the project and the game.